Students of 12th class, this is your another chapter, polymer chemistry from organic. Already you have studied the unit 1 solution, so I think that chapter is from physical chemistry. So next I am going to start one easy chapter which you can easily understand and note it down and use this for your daily life, because this chapter is very important in organic chemistry, that is polymer chemistry. Polymer characteristics and classification given in this chapter. So definition of polymer. Polymer, a very long molecule composed of repeating units connected by covalent bonds. Repeating units means what? Suppose you have various flowers of marigold or any other flowers of the same type, or 2 or 3 different types of flowers there. You want to make it in a garland or join these flowers in a garland. So in the form of garland, when all the flowers are collected or joined, that is called one type of polymer. You can understand it very easily. Or monomer, a repeated unit in a polymer. Monomer means what? Single unit, single molecule. And polymer, which is repeated after joining or after the chemical reaction, when all same type of or 2 or more different types of atoms or monomolecules joined there, that is called polymer, and the whole process is called polymerization. Characterizing a polymer on the basis of structure or classification or synthesis, 3 way polymer can be characterized. So on the basis of structure, 2 types of structures are there: skeletal structure and chemical structure. How? You can see on your screen one skeletal structure there given, that is linear chain. Linear chain means one by one every carbon are joined there. Actually what happened, students, you know that carbon has a special character, catenation. Due to catenation, many carbon atoms can be joined there in a compound. So in polymer, actually bond is formed between the carbon, a long chain is formed. So it may be linear or may be branch. So on the basis of a skeletal structure, first type of structure is linear structure, in which 2 ends are open. You can see or you can understand through the example this. Another is skeletal structure is branch shape, the chain structure in which side chain is formed with this. Already you have studied it in IUPAC nomenclature or in the other compounds. So it is easy to understand that when in a single line 2 or 3 other branches are added there, that is called branch chain. The same way polymer is formed here also. Cross-linked, another structure in which 2 long chain or simple normal chain joined with the branch or cross line, that is called cross-linked structure. I think in this structure or in this video, the figure which is given, it is easy to explain or easy to understand. The green long lines are the cross chain joining in this. Chemical structure. On the basis of chemical structure, homopolymer and copolymer are the 2 types of polymers there. Homo means as the same, only one type of monomers are there. Several repeating units which are having the same properties or same compounds are joining in a polymerization process, that is called homopolymer. Example, polyethylene or starch or cellulose are the example of this. And copolymer, more than one type of monomers are joining there. For example, polystyrene, nylon or artificial synthetic rubber. In copolymers, two types of bonds are there. You can understand through the figure. In first, alternating means first one atom, one molecular at one type of molecules joining with the other type of molecules, means two different compounds, one by one molecule attached there. And in block type of, suppose A and B are the two types of molecules. First, some molecules are polymerized, and then B in a 2 or 3 number, then again A, like this. That is called block formation. Or other is graft. In a branch chain, graft is formed. The straight chain or main chain is formed with a one monomer, and other monomer is attached with as a branch. On the basis of the property or with temperature, classification of the polymer as three types: thermoplastic, elastomer, and thermoset. Thermoplastic are the polymers in which linear branched types of polymers present, melted, which can be melted when heat is applied, can be molded into any shape with processing techniques such as injection molding or extrusion. Most common plastics or cap of a water bottle are the example of this. Thermoplastics bottles, grocery bag, water piping, rope, fishing line, car parts, which are recyclable, and silk, cellulose, polylactic acids, these are natural thermoplastics. Code for plastics, some word which you use: PETE, soft drink bottles, PETE, polyethylene tetraethylamine, LDPE, plastic bags, PVC, polyvinyl chloride, water pipes, same HDPE, milk jugs, PP, bottle caps, and PS, styrofoam. These are the code for the plastics. Elastomers, another type of polymers on the basis of their temperature or effect of temperature, that is cross-linked polymer. Rubbery polymers that can be stressed easily, rapidly recover in original dimension when applied stress is released. Low degree of cross-link are called elastomer. Rubber-like substances is elastomers. Examination gloves or rubber bands or bouncing balls, which these type of elastomers or polymers are not recyclable, degrades when heat is added, burns or scorches, shrink. Natural elastomers like natural rubber or latex are the example of these elastomers. Now thermosets. Normally these are rigid type of material, network polymers in which chain motion is greatly restricted by a high degree of cross-linking, cannot be reshaped once formed. Epoxy is the example. Other high temperature electrical applications: super glue, countertop, laminates, epoxy resin, tires. Tires is type of vulcanized rubber, cannot be recycled because on heating it burns or scorched with the heat. And natural thermostat means naturally occurring rubbers when modified with sulfur, that is called vulcanized rubber, is example of thermosets. So students, up to this is the first part of your polymers. Hope so you will understand it very easily.